Hello YouTubers, welcome to part 3 of this series. Before we dive in, let's see what we will be covering today. We will work with mainly the downloaded plugins such as Limbo for state machine by making an inactive state and some basic setup for our camera. So the table of the content is downloading required plugins, then we have setting up state machine nodes for our controller, then we will try to code our inactive state for some control behavior, then we will set up our basic camera. So the prerequisite for this video are video about state machine with Limbo AI, and that's available on my YouTube channel. So the requirement is high, and then again a video on controlling our animation tree node using GD script, and the requirement is again high because this will teach you how to control all the nodes and understanding state machine better. So then I have a smooth walk to idle transition. Again, the video is uploaded on my YouTube channel. Again, the requirement is high for that, and some basic programming knowledge so that you have some understanding of what we'll be doing. So again, the requirement is low for a basic programming. Now let's see what previous recap we had in our last video. So in the last video, we created a player setup, built an animation tree graph, and added some basic state machine for the graph. And if you did not watch the video, then please do it before going further so that you have some better understanding. So now let's start downloading plugins that we will use in our series. So the first plugin we will be using is Limbo AI. And currently I am using Godot version 4.4, so I'll be downloading this plugin that supports my current version. So let's click on the AI, then click on download. We'll use this plugin to have a state machine behavior for our character, so let's click on install. Rather than creating the state machine from zero, I feel like this plugin really helps me a lot to have some behavior effects on our player. So now once you have installed the add-on, you can just click on OK. Now the second add-on we will be using is Phantom Camera, and even this plugin will be very useful for our series. So let's even download this and let's click on install. Cool. Once both plugins are installed, we need to activate one of the plugin, and that's this Phantom Camera. So click on enable to turn on this plugin. And by the way, the Limbo plugin automatically gets activated once you install them, so no need to activate that plugin, but we need to activate this camera plugin. So once you activate, click on close. Now let's go back to 3D, and let me just make our animation tree inactive. Now it's time to add the state machine behavior for our player. So let's add a Limbo HSM. HSM stands for hierarchical state machine, and if you want to have the overview of these state machines and how to use them, go check out my video in which I will show you how to use this HSM as well as all the different states with a complete overview. Great. Once you have added the HSM state machine, then add the Limbo state, and let's duplicate the state 3 to 4 times. So basically 4 times, and let's rename all these states to be active. Then we will have a inactive state, and we will have a false state, and the last state will be aim. Cool. Once you have renamed all the states, let's attach some scripts for all of our states. So select any of the state, and then let's attach the script. We will save our script maybe somewhere inside the player directory, and let's create a new folder, name it as scripts, and click on open. Then let's create the script. So this is just a basic script, and we will do the same thing for all the other nodes too. So let's quickly add scripts for our other states. Now let's also add the script for our main root node. So let's quickly add the script for that, and here we get a basic template of some movement, and we don't need any of the template. Let's erase it and start the code from scratch. So now let's start writing the script that will basically handle all these state machines, and the script we will be writing in this root node, that's basically character body 3D node, and we will start with referencing all the 4 different states at the beginning. So let's start. Export variable inactive, and the type will be of limbo state. We'll do the same thing. Let's copy these both keywords, then paste. The next state will be active, and again that's gonna be limbo state. The next we have the aim state, that type will again be a limbo state, and at last we have the fall state, that's again limbo state. Once you are done with this, let's also create a reference for our animation tree node. So let's write already var animation tree, and that's equal to the animation tree node. Great. Next, in the ready function, let's capture our mouse mode so that we don't have the mouse arrow visible when we run our game. So to set the mouse mode, let's write set mouse mode to be mouse mode captured. Great. And then we need to initialize and set up our state transitions. So if you don't know what functions I'll be writing now, please go ahead and watch my video on overview of setting up these state machines so that you will have a better understanding what we are doing right now. Let's create a function for initializing state machine, and here we will say limbo state dot initialize. And by the way, we haven't created the variable called limbo state, so for that let's create again a onready var, or let's create a export var naming it as limbo state, and the type will be of limbo HSM, so that we will create the reference for this hierarchical state machine too. Cool. Now let's initialize our first state as inactive, because whenever we run our game we want the inactive state to be at first, and then we'll also tell our state machine that next let's initialize our state machine, and the last one we tell our state machine to be active. Cool. And this initialize function expects one parameter, so we need to add a self argument. Let's also quickly select our main root node, and let's fill all these assignments. So either you can just drag and drop with the respected boxes. So the active state goes in the active box, the inactive goes in the inactive, the fall goes in this fall section, the last one is the aim, so let's even assign that. And yes, let's also assign this HSM. Cool. Next, let us create a function to set up our state transitions, and inside this function we will just add the logic like from which state to which state our state machines can transition. So let's say that our state cannot transition from inactive to direct aim, so it first needs to go from inactive to active, then it can go from active to aim, and the similar for other cases. So that's why we need to add logic that represents how our state can transition. So let's add a transition so we can go from inactive to active state whenever we call this to active keyword. So that's basically the event name, and we'll do the same thing. So let's copy it up, and the next is we can go from active state to inactive state whenever we call a inactive event, and we can also go from active to aim state whenever we call to aim event. We can go from aim to active whenever we call to active event. Next, we can go from inactive to fall state whenever we call to fall. Also, we can go from active to fall state whenever again we call to fall. And we can also go from aiming to fall state. So maybe our player is drawn an arrow and then suddenly he moves out of clip. So at that time, yes, we need our player to have some fall animations so that he can go from our aim state to fall state. Then let's go from fall to inactive so that whenever the player reaches ground, he goes back again to inactive state. So the event will be inactive. And lastly, we can go from fall to active whenever we call to active. Cool. And just a point that we cannot go from fall to aim, because when we fall from a clip, we will just release our arrow, then the player will fall from the clip, he will land on the ground, and then he goes to the active state. So it's not something like whenever the player falls to the ground, he again grabs the arrow and then he releases it. So that state is not possible. So that's why we don't add that state. Cool. So the total number of transitions are 9 transitions. Let's also call these functions inside our ready. So we initialize our state machine and then we set up our transitions. Cool. Now the last function we need to add is the change state. So basically we added the transitions, we also set it as active, but we need to add the function that can try to change state from one to another. So let's create a change state function, and this will take the argument as state name. So from which state to which state we will be going. So the state name is gonna be a type of limbo state, and then we have the state that will be of type string. So we go from the state to our next state. So we dispatch the signal and the signal will be the state. So basically we say that the state name, so whenever we are in, let's say, inactive, so the code will be something like inactive, we dispatch the signal, and from inactive we go to, let's say, aim, so we just write the name as to aim. So basically we travel from inactive to to aim. So this is how the code is written, but it's for all of the functions, so we no need to write the same dispatch signal again and again for different states. So we'll just call this function from any of the state and this function will be triggered, so it avoids duplication of code. Cool. Now let's save our scene. Now let's start scripting our inactive state. So let it be at the top, and let's click on the script icon. We will delete all these extra stuff, we don't need them. We will write it from scratch. Great. So the first thing we will do is whenever we enter this state, we will just have a simple print statement that prints entered inactive state, and once we exit this state, we'll just copy the same print statement and we will write as exited inactive state. Cool. Now what does this exit and enter functions come from? Well, these functions come from the limbo state, and if you want to have the complete documentation, you can find it by pressing F1 and then you can search for limbo state, and you'll get the list of all the functions, the list of all the properties that this node contains. Cool. Let's go back to our inactive state, and here whenever we enter our inactive state, we want to traverse to this point. So basically, whenever we are at the any state, whenever we traverse to this state, we want this state to set as active. So to do that, we need to write the code, and here all the logics that control all these behavior, we will be writing them inside the animation tree, so that it becomes easier for us to call any function, and also the animation tree will help us to have the direct access on all these nodes. So let's also attach a script on our animation tree, and the script location will be again in the script folder. Then click on open, then let's create the script, and here let's again erase all the default code and let's write it from scratch. In this script, at the beginning, that basically at the ready function, we will set the animation tree to be active. And why we need to set is, we just made the animation tree to be inactive, so we will trigger this active function as soon as we run our game. And next, let's create a function that will change the transition for all of our graph. So let's call the function as state transition, and here we need to specify to which state we want to transition. So let's add an argument that will be of string. So first we get our state machine transition node by calling the get function. And if you don't know what get function is, you can open up the documentation for this node by pressing F1, and then you can search for, let's say, animation tree, and then that's this node. So I don't think there is an underscore, and you can get the documentation of this complete node in Godot itself. You'll get all the functions and what various different kinds of stuff. So let's go back to the script again, and here let's use this get function. So first we get our playback, and if you don't know what exactly I mean, so basically if you select the tree, then in the parameters you will have the playback of the animation tree as the state machine playback, and then all these functions, like all these stuff are the graph that we created. So all these are listed in this inspector section. So if you do any changes, then also you will see the reflect of those changes in this. And if you want again to have a more deeper knowledge, just go and check my video where I have explained on how to use all these nodes using GD script, so that you'll have some better understanding on what we are currently doing now. Cool. Next, once we get our playback, we will just call the travel function of our playback, and we need to travel to the state name that we specify in the argument. So basically it means that if we specify the state name to be active, then we will travel to this state. So it's similar as we click on this triangle. So currently it's inactive, but if you click on this triangle, the state goes from this to this. So the similar way the travel function does. And if we want to go to inactive, we'll just specify the inactive state, and then we will call the function, so it will go to this state. So now let's call this state transition function from our inactive script. So to call the state transition function, we will call the function by going through the character body reference, and then we will go down to this node. And if you remember that in our character body 3D, we just created a reference of our animation tree. So we will call the function by going through this node and then going back again to animation tree. So to do that, in our enter function, whenever we enter our inactive state, we'll just call our agent. So agent basically means the root node, so we just call it as agent, and then we call our animation tree. So agent is basically the root node, and this animation tree is the variable name that we had in our root node. So we just call agent and then we call the animation tree. So now the animation tree is the reference, so that's basically the reference of this node, and inside this we have the function called state transition. So let's copy the function name, and inside the animation tree we need to call this function, and then we just specify the argument name, so which state we need to travel, and the state name for our inactive is basically this name. So let's copy it up, and we need to traverse to this state. So whenever our inactive state is active, then we just travel to that state. Cool. Next, let's create a function of update. So update basically is similar to process function. So in this function, let's grab the input direction. So that's basically whenever the user press any key for movement. So let's grab the input dot get vector, and the person may press A, or the person may press D, or let's say the person may press S, or he can press W. So basically the person can press any of the keys from WASD, and we just normalize this so that whenever the person tries to press any two keys, then our input will have a proper value. Cool. So once we normalize this, if the length of our input direction is greater than 0, which basically means that the user has pressed any input and we need to move our player according to that. So next, let me just write few lines of code and I'll explain them all together. Cool. So now let me explain what these lines of code do. So here the speed is the variable that defines how fast we want our player to move, and then we get the root motion position with the z value. So basically the z value determines the forward axis of our player, and we get the z value by calling this function of our animation tree. And if you remember that the root motion is completely set on our animation tree, so we get its z value and then we divide it by our time. So basically this code gets the velocity, how far we want our player to move, and Godot actually doesn't know how to move using this root motion, so we need to convert it to velocity. So that's why we divide it with time and then we get the velocity. And also now we need to determine that, hey, which direction we want our player to move. So basically we get the player's forward direction by asking agent. Agent is basically again the root body, that's our player. Transform basis dot z gets its forward direction, and then we determine how fast we want our player to move. So basically velocity helps us to move our player. So in x direction we want our player forward dot x. So then we state our player forward direction with our speed, and then we also specify the same thing for the z-axis. Now why do we need both x and z-axis? And that's because maybe for current the player is moving in z direction, and in future the player may turn to right or turn to left, and then we want the player to move in a right direction. So that's why we add both of this code. And this line, initially we set our movement to -1, and that's because we control our blend space 1D. So here we need to have this pointer to go from idle to walk, and then we want to go it to run. So this pointer is controlled with this movement variable. So we just lerp our movement to 0 whenever we press our movement key with the speed of 3 times delta. So we just try to move this pointer. We don't actually try to move the pointer, but we try to create a variable that can move this pointer. So now to exactly use this movement variable to control these positions, let's add a function in our animation tree. And as I said previously that any changes for any of the nodes will be made through animation tree. So we will write the function in that, and then we will call the function in our inactive state. Cool. Let's create a function, name it as inactive movement, and this will take the argument as blend position. Let's call it as value, and that will be a float. Why float? That's because these values are of float, so we will take the argument as floating point value, and inside this we need to set few parameters, and I'll just explain why we need to set these parameters, but let's just blindly write them. So now let's see what exactly I am doing. And by the way, I said that if you open up the movement in your inactive state machine inside the animation tree, here we just added these points. So we added this and this point, so this one. So we added this point, and inside that we added our walking animation with the time scale, and also we added this second point with again the run animation with time scale. So we need to add this time scale to have movement or blend between walk to run properly. So for that we need to add these both lines. So we manually control how fast we want our player to move, and also the last line, I mean this line, is mainly used to control this pointer. So we can go from walk, I mean from idle to walk, and then run. So this controls, like this point is controlled using this line. So these both are for to have a smoother blend between walk to run. Cool. Now here we actually get the walk as well as run length, and based on this we actually set the speed of this time scale. And if you want to have some more information about like how this exactly works, you may just follow this GitHub thread, which has the similar explanation and the similar stuff. Now the animation walk length and the animation length run are two variables or two constant, and here we need to specify how long our animation length actually is. So I just wrote 0 as initial. Now let's quickly see how long the animations are of length. So let's go to walking, and the length of this walk is like 1.066. so let's write it as 1.066, and for run it's 0.766. Cool. So now we just entered both the walk as well as run, and based on that we actually set the time scale of walk as well as run, and this 1 and 2 are the points inside the blind space 1D. Cool. Next we'll call this inactive movement function inside our inactive state machine. So let's call the function by calling it as agent inside the animation tree dot inactive movement and the blind space value, so basically the position value that we calculated in this movement. So let's call it here, and then we just say our agent or the main root node to move and slide so that it actually moves in the physical space. Cool. Now let's quickly add these ASD keys inside our project. So let's go to project settings, under input map let's add a action. Let's just write the keys as WASD, and inside this plus icon of a respected key let's add the same key. So for W it's W key, for A it's A key, for S it's S key, and for D it's D key. Cool. Now it's time to check the working of our code. So let's save the scene, let's create a new scene. So let's click on the plus icon and the new scene, let it be a node 3D for now, and inside this let's add a CSG box and let's roughly scale the box. And by the way, if you press Alt and then if you drag, you can drag from both of the ends of I mean the here and here as well, so you can just see. Now let's select the box and let's also see that use collision is checked on. Now let's add our player controller. So right click and then instantiate selected child, and then here let's search for player controller, and the shortcut key is Ctrl Shift A, which opens up the same dialog box. So let's select for player controller. Make sure you select the player controller, not this one. This is the example of the phantom camera, so we don't want that. So let's add the player controller that we created, and this opens up our actual player. So let's place it on the ground. Let's also add a dummy camera for our player controller. So let's add a node 3D camera manager will be the name of this, and then let's add a camera 3D and let's position it somewhere like this, so you can quickly see how we are placing our camera. So let's also rotate it somewhat down. Cool. Let's open up this, and now we have our camera attached. Let's save this scene, press Ctrl S, and let's name it as world. Let's save the scene, let's run this scene now. Okay, you can see that whenever we try to press WASD key, the player actually starts to move, and once he moves to the ground, he's going far away from the ground. That's fine. It means that the movement script is actually working. So this script is actually working, and yes, that's cool. Let's also quickly add some sun as well as the world environment, so that our game runs in is same bright as that looks in the 3D workspace. So now let's try to move, and yes, the player starts to move. That's cool. Let's quit this, and let's now start to implement other stuff. So now let's add the code that makes our player, walk to stop or walk to run. So for that, let's quickly delete all these scripts and let's create a function for that. And the function name, let's keep it as set velocity, and let's paste the code. Great, let's call this function from here. So now if you have watched my video on how I made a smooth walk to stop transition, then it's better so that you'll understand more. If you don't, then we are just using a tween, to control the blend point position, the movement of the blend point position. So let's here write the else condition. So if we are not moving, that means we want our player to stop, and to have a smoother stop, let's add a tween. So let's actually create a variable for tween, and we will set it to false. So if there is no tween, then we actually create the tween. We attach it to this same node, and then we create a timer variable that will determine how fast we want to move from walking to stop. So basically I want it to be of 1 second. Initially the movement value will be 0, because again the point goes from -1 to 0. So when we are walking, the movement value will be let's say 0. So I want the time to be 1 second to player can go from walk to stop. So then let's say tween dot tween property, and we want to tween for self. The variable will be movement. It should go to -1 with a duration of time, and then let's set the easing function with tween dot ease in out. If you don't know what exactly this tween dot ease in out, then yes, please go check out my video where I have clearly explained what all these easing functions are. Okay, so next let's also set the transition type by using the set trans function with tween dot transquint. Cool. So once we set our tween, then we will again set the velocity at this point. And you may ask like, hey, why can't we just write a single velocity at this point? And this is not how it works. We need to set the velocity, we also need to calculate the movement, so that's why we write it two separate functions. Now if we try to move, then we can set our tween value again to 0, so that again our stopping will properly work. So like whenever we are trying to move, we'll set the complete code to reset. So as soon as we stop our moving, again we easily create a walk to stop cycle. So that's why we set our tween as 0. Next let's add the code for run. So to do that, if we press the shift button, so if input action press shift, Then let's basically copy this. We'll from movement to 1. So basically, if you press the shift button, then this slider should go to point towards 1. So we specify here as 1, and let's increase the speed so that the transition is much faster. Great. So let's also clean up this function, and let's also add this shift in our key mapping. So let's go to project settings, again in the input map. Let's add the shift, and it will be the left shift key. Then click on close, and I think it's better if we create a function just to check if we press the shift. So let's go down, let's create a function, let's call it as should run, and then we paste. So inside the should run, if we press the shift key, then return true, else just return false. Now why we are creating a separate function that will be useful in our future when we have a camera with all the script on camera manager, but initially this function is very small. That's okay. So let's copy this function name and let's call it here. So if we press our should run button, then we just make the movement much more faster. If not, we make the movement slower, and if we release our shift key, or if we release any of the key that doesn't move our player, then we just make our player to stop. That's everything. Let's again try to run our scene now. Let's press W, and you can see that now our player starts to move, and as soon as I release W, the player stops. Let's also check if the player is actually running, and yes, you can see that there is a smooth transition movement between walk to run. There is no glitching of legs, and that's cool. And as soon as I leave, the player stops. Cool. Let's go back to script. Now let's start scripting our third person camera. So let's attach a script to our camera manager. So let's even create the script inside the script folder, and let's delete all these codes. We'll start from the scratch. So before that, as we installed the phantom camera plugin, the phantom camera needs some setup so that it can start work on our camera. So the first thing that we need is we need to add a phantom camera host. So that will be the child of our main camera 3D, so that it can actually send the data to the main camera. So let's try as phantom camera 3D. So this is now the actual main camera that will be working on our script, and this is a kind of host that's attached to this main camera so that it can communicate. And yeah, this looks little funky to do, but this is how the plugin works. For more information on the plugin, you can for sure go and read the documentation. And let's rename the phantom camera to main camera, because this will act as the main camera. Cool. Now let's write some script inside our camera manager, and at the beginning we will create a reference for our main camera. So this is the manager, and we want to have control on this main camera. So just forget about this camera 3D. So this will not act as the main camera. From now onwards, this phantom camera will act as the main camera, and we will be controlling this node, thinking it as that this is our main camera. Now let's create a reference for our main camera by writing this code. Next, let's have some variables. So now what are these variables? So basically we have the mouse sensitivity that determines how fast we want to move our camera, and then we have this min pitch and max pitch that determines the top and bottom angle of our cameras, and then we have this min yaw and max yaw that basically determines the left and right rotations. So we can just rotate from 0 to 360. That means we have no restriction in horizontal rotations, but we need some restrictions on vertical rotations. Cool. Now let's script our third person camera. So let's create a function, and the function is the input function, so we don't create it, it's an built-in function. And in this function, if event that it's captured is input mouse motion, then we create a variable So this is the line of code that we need for the third person setup. So basically the phantom camera contains a third person setup, and in that we add our the max vertical rotations with the times of mouse sensitivity. So basically first we get how much our mouse has been moved, and then we multiply it with our sensitivity, and then we clamp it so that it doesn't go beyond our max angles. And we do the same thing for our horizontal sensitivity, but this time we use the wrap function. That's because rotation degrees cannot be clamped using the clamp f. That's because it starts from 0, it goes to 360, and then it goes beyond 360. So the rotations keep on increasing as we round around and around. So we cannot clamp the rotations in degree using the clamp f, so we use the wrap f, and then we set our settings that we add to our third person camera controller with this variable that we just changed. Cool. So now let's select our main camera, and in the inspector you'll see that we have some properties that we can actually change on our main camera. So if you try to change the camera properties, then you see that it can't be changed. Like you can't even change the position, you can't change the rotations. So as I said that this camera is now completely useless, we need to change everything on this camera. So the first thing we need to change is the follow mode. So we want a third person controller, and our follow target will be our main character, and then we don't want to tween on loading. So this option basically means that whenever we start the game, the camera goes from 0th position to the position where our camera should be. So we don't want to tween, we basically want our camera to be static at the same point when the game loads. So next, the look mode is set to none, and twin resources is completely optional. The next thing that we need are camera resources. So we'll be using this same camera resources at this point. So we'll see that we get all the options like FOV, near, projection, H offset, vertical offset, etc. So the next thing that we need to change is basically the follow offset. So if the follow offset is set something like this, so that's basically targeting our player leg. so we need to change the height of it. And also next, in the spring arm, we need to change the rotation, either the vertical or the horizontal, to be 180, so that our camera looks kind of third person. And then we also need to change the spring arm length. So initially it's set to 1, you can just change it somewhat, maybe 1.7, and also slightly the vertical rotation to look downward. For now, let's say for temporary, I'll just place the camera position above the player somewhere at this point, and it actually looks downward towards the player. Cool. So let's now test the scene. Okay, we have a problem that we can see left and right, but we can't actually look up and down. That's okay. So now let's try to move. Cool. So let's fix the issue of the vertical clipping. Yes, so we here used the clamping, but we need to set this pcam rotation as minus event relative and then the mouse sensitivity. So now it should work fine. Yes, okay, the rotations are too high, but yes, this looks somewhat okay. So now let's change our player to move in the direction we are facing. So basically I want my player to move in the opposite direction, let's say in this direction when I press W, but the player is still moving forward. So let's fix that. Let's jump back to our player script in the inactive. At this point, so whenever we try to move, then our player should get the camera axis, and then it should rotate towards which direction we are facing. So it should only work whenever we try to press any of the keys from WASD. So we will write the code at this point. So let's write camera forward, and then that's equal to our camera. So basically now we need to access the camera, but cannot directly access the camera from this point. So let's create a variable at the root, and let's call it as onready var camera equals to our main camera. That's basically this node. And in the inactive, let's call agent dot camera dot global transform dot So I have finished writing the code, and basically the code states something like this. So basically at the beginning we just get our camera forward and camera right direction, so that we know which direction to move our player. So then we calculate our move direction. So if our player is facing camera forward, and if we try to press W or S key, then this logic will work. But if our player want to move towards right, and if we press any A or D key, then this logic will work. So that's basically we get our movement direction and we normalize it so that it doesn't exceed much. We also get our target rotation, so that which direction we want our player to move, and if our player isn't facing in that direction, then we just rotate our player by using the lerp angle function with our target rotation, and then we specify the speed with our rotation speed as well as the delta. So here the rotation speed is a constant that I have created. So this constant determines how fast our player should rotate towards an angle. So the value I have set is 7.0. So let's check it out if it works. And you can see that yes, the player is rotating in the direction where we are facing our camera. And if we don't press W and we just rotate the camera, then still the player doesn't move towards the camera, and this is great. So the player only rotates when we try to move. And yes, you can see the player even moves in right or left. So this is cool, but there is a problem, and you can see that the player is moving really slow. And also there is one more issue, and that's the leg glitch. So you can see that there is a slight glitch between these legs. So let's fix these two issues quickly. So the first thing we need to change is the speed. So maybe a speed of 3.5 will be good, because this speed is used to set the velocity of our player. And then to fix the leg glitch, let's go to animation tree, and in this blend space 1D we need to turn on this sync. So this is very crucial to make a smoother blend movement. Now let's try again, and yes, this time the player is moving much more faster. And also let's try the leg movement, and you can see there is no glitch between the leg movements, and also the player is moving at a faster speed. So if you didn't like the current speed, then you can just change the speed constant to have a player move at greater speed. Now before actually cleaning up all the mess code, I just found one more glitch, and that's basically, let's try to move our player, and as soon as we leave the W, and again if we try to press the W, you can see that the player goes to a complete stop, and then the player tries to move. So if we are running, and then if I leave, and then if I press the W, you see that the player goes to complete stop, and then it starts to move. So to fix this issue, let's go back to our inactive state, and here instead of directly setting the tween to 0, we need to write if condition. So if we have a tween, then we first kill our tween, and then we set our tween to null. And let's try it now. Okay, we need to run our void scene, and let's move, and then let's move again. Yes, so if we run and then if we move, yes, it's moving perfectly. Great. So that's it for the coding part in this video, and now let's start cleaning the mess that we just created. So we will properly organize the complete code of our character as well as some other stuff, so that it looks more professional and more reusable. So let's see what stuff to clean. And I see that this set velocity is mainly based on our agent, and our agent is the main root. So I think we can just cut this code from here, and let's add it here. And instead of agent, we just specify directly as animation tree, and we just remove all the agents. And also that this requires a speed variable, so let's also copy the speed, or let's cut it from here and let's paste it at this point. And now you'll see that the name set velocity can't be assigned to character body 3D because this name is already grabbed by the node. So next, let's delete the agent. Cool. Now let's call the set velocity by saying agent dot set velocity. So we call the velocity function from our agent, and let's do the same thing at this point. Great. Next thing that we need to clear out is the rotation part, because everywhere we are just using the agent and this looks kind of mess. Also maybe in future when we go to our active or aim state, in that case too we want to have the same logic that our player should turn towards our camera facing. And yes, we can't just write the code again and again, so let's cut the code from here and we will paste it in our main root so that we can easily access this function anyway from our script. So let's quickly rename it as rotation based on camera, and let's delete the agent stuff. Okay, so this requires the input direction variable as well as the rotation speed variable. So let's copy the rotation speed, the rotation speed from here, and let's paste it below our speed. Then it requires the input direction, so let's create an argument, call it as input direction. That's gonna be a vector 2. Cool. So let's go back to our inactive, and before that let's copy the name. Let's go to our inactive state and let's call the function of our agent with the argument of input direction. And other than this, I don't think there is. I think we also need to change this name, that's set velocities, and I don't know what exactly to name for this, so and I just typed some random keywords. Great. Next, in the animation tree, I don't think we need to change any other things, and this is fine. Camera manager, even this is great. Now it's time to see all the scripts that we have made. So that's it for this video. Let's see what progress we did in our current video. So we downloaded and set up our plugins. Then after that, So we built state machine nodes and scripted behaviors of those transitions. Then we implemented a inactive state. Then we added our animation tree helper functions so that we can easily control our animation tree. Then we created a smooth idle to walk or walk to run transition. And then we set up our camera using phantom camera host. And the last one was cleaning up our project with all those mess. Before we wrap up, if you enjoyed this video, then don't forget to hit like, drop a comment, and also subscribe for more future content. And if you'd like to go with an extra mile in supporting me, then you can just grab the potato card membership on my itch.io for just $1. Every bit of this support really helps me for keep me creating more stuff and improving for you guys. Thanks for watching, and I'll see you in the next one.